Hello Gophers and welcome back to part 19 of Introduction to Go. In this video, we'll be understanding about Go routines. Before we move forward, please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss out any new videos or tutorials that we put forward. Topics that I'll be covering today in this video are how to create a Go routine and synchronizing between n number of Go routines using weird groups or mutexes. Now, Go has created an abstraction over the threads that are implemented by the operating system. So the actual threads that are used by the other programming languages that are, let's say, Java or C Sharp, those are very heavy loaded threads and create a larger memory imprint on your operating system. That is why those threads, creating and managing those threads are very heavy in other programming languages. Now, in Go, these threads are actually an abstraction which are referred to as a Go routine, and they are of much lighter weight and much more easier to get maintained now. That is why in Go you can have thousands of threads running in parallel, which cannot be run in other similar languages, let's say Java or C Sharp. These threads are normally also called green threads in Go also, and Go routine is one commonly used term for these threads. To manage these threads, Go has created scheduler which will keep switching between the threads, and the scheduler is also optimized to a level where it is capable of handling thousands of threads in parallel in single, let's say, on a single box. So that is why in Go, parallelism is very fast. Creating a coroutine or creating n number of threads will be much more faster in execution as compared to other programming languages. Now let's start by understanding how we can create coroutines and how we can start synchronizing between different Go routines. So now let's start by understanding how we can create Go routines. Here I have a variable which contains the favorite chocolate. Maybe that's my favorite chocolate, you can take it. And I have created a function that just prints that this is the most liked chocolate. And in the main program, I'm just calling this print function. And let's run this program and see how it behaves. So it says most liked chocolate is galaxy. Now, if I want to run this in background or in a Go routine, the keyword that I need to use is Go. Just add the keyword go in front of the function call, and this will run this in background. Now we didn't get the output printed on the screen because the main Go routine, so any Go program will contain one Go routine at least, and that Go routine contains the main thread, the main program thread. So in this, what happened is the main thread got ended first and then this was getting executed. So when the print function was trying to get executed and was trying to access the console, it did not get console because the main thread got ended before that. So just to do, just to check if things are working fine, I'll just create a thread sleep. Now that's not a perfect way to handle this scenario, but right now let's consider this for this example for time being. Let's say I'll wait for 2 seconds and then try to finish the main thread. Now you can see I've got most like chocolate is galaxy. So that means this Go routine was actually working in background but did not get the instance where it could have printed the actual value that it was supposed to. So this is how you can normally run a Go routine. Now to do this, let's also try and change the value of chocolate to some other value, let's say Mars, or let's say silk. So now let's try and run this program and see. So you see that over here it got printed as silk because but our print method was actually called before we changed the value. So why did this happen? Because now GoRoutine is trying to access a variable that is in another scope or the parent scope, and as soon as it was trying to execute this function, the value got changed, so it will access the new value of the variable. So to handle such scenarios, you should normally do not have to refer to a global variable if you do not intend to get or access the changed value in the Go routine. So what we normally do is we pass the variables that are needed in the Go routine. So I'll pass this, and let's say I'll have a variable, say favorite chocolate over here of type string, and then I'll print this instead of the global variable. Now to check if the value got changed or not, let's try and print in main. So main function, I'll print this so that we know that from where the particular statement is coming from, the print function. Now let's run this. Now you can see from the main function it's print silk, and from the print function it is printing galaxy. This is because you have passed the particular value to the function, and now it does not care if the actual variable has changed or not. So this is how you can start writing a Go routine or start executing Go routines. Now let's try and understand more deeper concepts in Go routine. Now, in normal scenarios, you don't have to use the thread sleep method, because this is also not a recommended way to stop your program or stop the console from getting ended, or to synchronize any Go routines. So, because in the function that you might put in a background thread or a background routine, you might be doing some calculations that are heavy on the process, and as load on the system increases, it might take some extra bit of time than what it took when you were developing it. So you will not be anytime sure that how much time actually you should be waiting for that process to complete. So to handle these situations, Go has given us a wait group. Now, how to use wait group? Let's start discussing on that. Now, to use a wait group, we'll have to import a package named as sync, and this sync package has a struct of type wait group. The struct has three basic methods that are declared or that are there inside it. Those are add, done, and wait. Now, how to use all these three? Let's start by understanding that. Now, I have created a wait group object for me for that type struct, and then whenever I am adding any function to get executed in a Go routine, I'll call a wait group dot add method, and I'll add the number of threads that I'm trying to add. Let's say if I add this same thread two times, so that means I am adding two threads to a wait group to a Go routine. Then I'll add a wait group dot add two. So this is how we can do it. So now let's remove this extra piece of code. Now, whenever the thread group gets uh, executed completely, or a code routine gets completely successfully executed, so we'll call a done method. This done will actually reduce a count of one from the wait group total count, and will help us in understanding that how many threads are actually pending. And in the end, I'll have a wait method. Now this wait method is actually waiting for all the threads to get executed completely, and then only it will run the statement that is listed below. So let's say I have a statement that says, sorry, that will get executed only once the all the threads are completed. So in this way, what I'm saying to the Go program is that go ahead, create a variable first, create a thread group, add a thread. Now add a thread means I'm going to add one thread now to the background process. This is the thread, and I have asked it to execute as well because I have used these parentheses over here. So this is gone to a background thread, and as soon as the thread is getting executed, then this done method will be called of the wait group. So it helps us in reducing the count of the currently executing threads. And I have a wait, and after this wait, I'll print the name of the person that I just changed just above the wait method. Now let's try and run this program. Now you can see that I have got the name John first printed, and then it waited for uh, this function to get executed and then only Tom. Now this is a quick method that got executed very quickly. So what we can do is we can add a thread sleep over here so that time dot so that we know that I'll wait for let's say 5 seconds. We'll try to wait for 5 seconds so that after we have printed the name John, and we should wait for 5 seconds so that after 5 seconds only we get Tom printed. So now we have got the output John, and after 5 seconds we got the Tom output printed. Now let's start by understanding the concept of mutex. Before we start understanding why you need to use mutex or how you should use a mutex, let's first understand the problems that might occur when you start using uh, Goroutines and you want them to be in a synchronous fashion. Let's say I have a small program, and this may look very simple thing to do, but yes, I have a program which has a print function and an increment function. The increment function's only responsibility is to increment the count variable, and the print function will print the count variable and a constant string. Now, I've used defer so that in case there is some unhandled exception or there is some panic that occurs in the function, we make sure that the wait method, wait group dot wait method, do not wait because the done was not called for a particular coroutine. So I normally write this in a deferred statement so that I am very sure that my my go routine is ended, even if there is some unhandled panic or something that occurs in the function. So now let's start. So what we'll normally expect out of this program is exception handler 1, 2, 3, and so on till 9. So from 0 to 9 it should print because I is starting from 0 and count is also starting from 0. So I should go from 0 to 9, and that's what the count should also. So now let's run this program and see if that occurs correctly or not. So if you see, I got 1, 0, 1, I didn't get the 2, and then I got 5 two times, I didn't get the 7 as well, I didn't get the 9. So what happens? So even if I try and run this, I'll not get the same sequence of numbers that I got in the first result. So I'm not every time sure that my output would be same or not. Now, what happens if I want them to be in the same sequence every time? Now, one thing that you could have done is call this increment function from from this function, print function. and you eliminate this one go routine. But that's a simple case that looks very forward right now, but there can be scenarios which you want to run in background, but like three different functions to run in background, but all those three should be synchronously as synced to each other. Now, how we can do that? Let's understand that with a mutex. So now I have created a mutex variable from the sync package. The mutex is rw mutex. That means read write mutex. So over here I'm saying that I want to create a mutex that creates synchronous effects on all the read and write operations. Now, how to start using a mutex? We first, just before we uh, do a write operation, we'll have a mutex.write lock, and then we'll perform the write operation. And in the write operation, after the write operation is completed, we'll remove the write lock. Then again, when we have a normal write block where I'm actually changing the variable, I'll create a mutex lock which will actually lock all the programs that get executed before executing this, so that no other go routine gets executed in the current execution when this function is actually executed. So I created a lock on this function. So whenever increment counter is getting executed, all the other go routines will stay where they were and they will stop executing sort of. And as soon as the increment is done, I'll have a mutex.unlock. Now, why I don't write all this in the function itself? Because those will be a background, and then again there will be some issues where uh, when increment was actually happening, it stopped some of the go routine and some did happen. So that is why we want this lock to be created in the main thread itself. So I create the lock in the main thread and release the lock in the goroutine function that we execute. Now, if we see and run this program, let's see if all the things get executed in a sequential fashion or not. Now you can see that 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and all is executed in sequence. Now this is sequence is always guaranteed because you have created locks and you have created a read write mutex. So this is how you can use mutex to synchronize between two coroutines and have uh, similar object if you have to be shared amongst the two and you want them to be in synchronous fashion, then you can use mutex as well. Yeah, but I would rather suggest if there is a way where you cannot where you should ignore mutex, yes, you should try and ignore a mutex because using mutex creates a lot more lengthy program and is less less easier for any other person to understand on the first round that why the mutex were used. So either you write a very well commented code or you don't use mutex and try ignoring the mutex. Now, we'll also understand how we can limit how many parallel processes a program or a Go program should execute in parallel. So, how we can limit those processes. And now that is very important when you are actually trying to optimize your program's performance. So let's say you have 1,000 coroutines that get executed in parallel at once. So you create 1,000 parallel requests. But that 1,000 parallel request is, let's say, on your own microservice, your own separate microservice. Now, creating 1,000 requests on your microservice in one go shall or will create a heavy load on your microservice server as well. So you can actually restrict those go routines to be run like in uh, you may say that run only four go routines in parallel and then after those are complete run those. So how many parallel threads actually you want your program to have? You can restrict that. Now let's see how we can do that. Now, how we can know how many default Go processes or max threads are allowed by the Go by default. So we have a method that is inside the runtime package and it is said as go max proc. So this is a method that actually gets the value or sets the value of maximum allowed processes in a Go program. So if I pass -1, that means it will not set anything but return me a value which was actually set by Go or you might have modified. So the number of processes that are allowed currently, it will get me that value. So let's go ahead and run this and see how many max processes are allowed right now to run in parallel. So it's 8. So ideally what happens is the number of cores that you have on your system, that is the number of processes that are allowed to run in parallel by default. So I have 8 core CPU right now on my machine. So that means it will allow me to run 8 different parallel processes in my Go program. So if you want to change this anytime, you can go ahead and use runtime dot Go max processes. Let's say I go to 50 processes in total. So ideally, this is recommended that you should at least run one process per core. So if you have a 16 core CPU, let's say, so you should have at least 16 processes running in parallel to get the max of the Go routine. But there is no let's say there is no limitation to number of processes that can be done in single core. So you can go up to, let's say I have 8 cores, so I can go up to 64 cores. That means 8 processes per core. So that is also allowed and that is also valid. But every time you go for a production environment and you want to release, you should actually test these that this value to get a peak point where you get the maximum performance, because you cannot keep increasing the max process count to n or let's say any value, let's say 1000 or 2000 to get more performance. That's not the case every time, because the more number of processes that you have will have more impact on your memory management of your scheduler. So now your scheduler has to keep rescheduling different processes again and again, and it should bring down your performance eventually after some point of time. So you should actually get to a sweet point where you know that this is the point where my application performs the best on these number of cores, these number of threads. So you should actually, before releasing to production, you should try and fine tune this that variable value. So this is how you can increase the number of parallel processes in Go. So that's all on Go routine, and let's see and understand channels in our next video. Thank you for watching the video. Please do not forget to like, share and subscribe to our YouTube channel. Also press the bell icon so that you don't miss on any new notifications. Also do comment us below on any feedbacks or any new tutorials that you want us to do.